Good morning. Good morning, everyone. I, Mohammad Tariq Sayed, Assistant Professor, College of Agriculture, Parul University. Today, we are going to start very interesting, informative, and productive webinar on role of nanotechnology to meet United Nations Sustainable Development Goals, current status, and the future. Nanotechnology monitors leading agriculture controlling processes, especially by its miniature dimension. Additionally, many potential benefits such as enhancement of food quality and safety, reduction of agriculture inputs, enrichment of absorbing nanoscale nutrient from the soil. Agriculture, food, and natural resources are part of those challenges like sustainability, susceptibility, human health, and healthy life. The ambition of nanomaterial in agriculture is to reduce the amount of sprayed chemical, minimize the nutrient losses in fertilizer, and increase yield through the pest and nutrient management. Nanotechnology has a perspective to improve the agriculture and food industry with novel nanotools for the controlling of rapid disease diagnostic, enhancing the capacity of plant to absorb nutrient along with the among the others. So today's topic is so different and having lot of opportunity in future. So without wasting more time, let's move on the our program. Let us introduce first and welcome our chairman of today's webinar, respected Dean and Principal, sir, Faculty of Agriculture, College of Agriculture, Dr. Chandrakant Sharma, sir. Good morning, sir. We have Dr. Ramesh Lalita, sir, General Manager, Research and Development, IFCO. IFCO introduced a first nano urea, break through the solution for the drawbacks and observe while the using urea. Dr. Ramesh Lalita, sir, is a scientist behind nano urea. He's a, he has been working on developing nano urea since 2015 and has been active participant in nano national worldwide trials for nano urea from 2019 also. Sir has licensed his invention for free to ensure Indian farmers and can assess his low cost. Thank you, sir, for being with us. Good morning, sir. Now, I would like to invite Dr. Chandrakant Sharma, sir. Please, sir, share your valuable words to our audience.
Thank you, Harikji. Good morning, everyone. Faculty of Agriculture, Parul University is imparting to the knowledge to the society under the dynamic leadership of our Honorable President, Dr. Devansh Patel. Sir. We are offering the different kind of the courses, like as the BSc in Agriculture, BTech Dairy Technology, BTech Agriculture Engineering, BTech Food Technology, as well as Animal Husbandry program. If you see the today's topic, which our guest is going to deliver on that, the role of nanotechnology for fulfilling the SDGs goal, present scenario, and the future perspectives. Nanotechnology is playing the significant role in everyone's life. Then how the agriculture can be separated from that? Dr. Ramesh earlier has developed nanofertilizer, which is marketed, which is sold, or which is a part of the IFCO also. So if you see, it is the technique of the future. Those who believe in the advanced sciences, nanotechnology is one of them. With these words, I would like to welcome all the audience and our chief guest for the today's program.
Now, I would like to invite Dr. Ramesh Lalita, sir. Sir, please share your valuable words to our audience, sir. Please continue.
Thank you for giving me an opportunity to meet and talk to all the students and faculty associated with the Parul University. I'm so grateful for giving me that opportunity, and I look forward to start with the presentation and talk about that how the new technology can help to meet the sustainable development goals, and what is their importance, and what are the other aspects, and I will give specific examples related to agriculture. So may I share my presentation?
Sure.
So I may need uh, your request that Can you see my screen, please?
Yeah, it is visible, but I think it should be in a
But
sliding
it's
mode.
presentation mode, right? Yeah. Good. Can you see
Yeah.
me?
Yes.
Okay. So, good morning to all of you. Today we are going to discuss about role of nanotechnology to meet United Nations Sustainable Development Goal, its current status and future perspective. Uh, First, starting, let's talk about what is UN Sustainable Development Goals and why we are talking about that. So, if we talk about that, then United Nations has established or identified about 17 sustainable development goals to achieve the better human life and to sustain the human life for generations, which starts everything related to the human life and human health. If we talk about related to whether it is poverty or hunger or health or training, skill educations or equality, whether it is genders or the access of the clean water or affordability of energy or work, like economical growth of the region, innovation, infrastructure developments, to reduce the inequalities, whether it is gender or accessibility of the resources, or developing smart cities and communities which are more responsible for consumption and production and better for the climate actions to have the greener or cleaner environment, whether it is belong to life on water or the life on land or the peace across the globe. And then the last part, which is really important, is talking about partnership or collaboration. When we talk about partnership and collaborations, that the new technologies integration comes, and this is much more important in today's time than any time else. Why we are talking about all these factors? Because these are influencing our life every day. Why this is important? Because why it is the need to achieve these goals now? Because we are facing various challenges, whether these challenges because of the societal pressure. And when I talk about societal pressure, this is a human society pressure, whether it is deforestation, whether it is waste disposal causing air pollutions, global warmings, climate change impacts, biodiversity losses, water insecurity, and plastic pollutions. These are not only limited to a particular geography, but this is for the entire world. Why we are having these kind of challenges? Because to meet the human need, but at what pace we are causing the challenges up, and how it is helpful for us, whether the challenges we are creating is solving our problems for today, but are these challenges creating more future challenge in the time to come? Yeah, like, and along with that certain other factors, whether it is education and skill training. Education, when I talk about education, because Parul University is an institute which provide a lot of skills in education across the India, but also other international students as well. So how the education and skill training is important and how it is distributed or accessible to the people, gender and cultural inequalities, and distribution of natural resources. If we combine both the factors, whether the pressure we are creating towards the environment or the other essential things for the human, if we categorize all them into just three things, this is about food, water, and health. And these majority of the things are dependent on agriculture. I kept here agriculture because human and ultimately all life form is depends on the plant, whether it is for the food or other minerals or other resources. And that's why the agriculture is one of the backbone to solve all these major problems, whether it is related to biodiversity losses, whether it is related to water insecurity or climate change or pollution or the deforestation or security of food, reducing hunger. So majority of the things are directly or indirectly linked with the agriculture. Then there is also a new concept coming or already being discussed, Society 5.0. This is first appeared when it was declared by the Japanese government for the betterment of the human-centric society, which can achieve both economic development and the addressing the societal issues using the sophisticated integration of both the physical world and the cyber world. If we talk about Society 5, let's talk what was the Society 1, where we are talking about the initial stage of the human development, whether it is hunting or gathering. And then Society 2, where we were talking extensively about agriculture development. Society 3, we transformed of the processing, whether it is food or materials like industry. And the 4, where we are currently passing through, which is like information technology and so on. In the new society, we are going to have the big role of whether it is data science, information technology, bioinformatics, genetics, biotechnology, nanotechnology, and those kind of integration which can solve the problems which we have discussed in the previous slide. So the question comes, why the nanotechnology we are discussing today and how it can solve the global problems, whether it is related to the sustainable development goals or any other goals which are important for today's world and the futuristic challenges. Whenever we talk about nano, the question comes that how it can help us. Because the one thing, as you can see in this picture, the nanotechnology is the core of all the technology-based solutions. Whether you talk, which is based on material science, the sensing technologies, surfaces, quantums, medicines, health, artificial intelligence, energy, you name anything, which is like I have described here in the circle. Like all the technologies which we are accessing today for the ease of our life, it is some sort of can be improved using nanotechnology. Why nano is improved? Because when we create any material at nano scale, it has different phenomena at its physical scale of nanomaterial or nanoscale, which provide or brings quantum effects. Quantum effects dominates over all other factors or properties of the materials. It plays different surface behavior due to high surface area to volume size ratio. It improves the biointerfaces when the material interact with biological surfaces or material interact with any external environments. It provides more interfaces or the area where the material can interact and provide more efficiency or the productivity. And because of that reason, Nano is providing incremental improvements. Like instead of incremental improvements, it provides disruptive game-changing breakthroughs and innovations. Whether you talk in fertilizer, one example we will discuss in more detail later, or whether it is automobiles, sensings, or any other applications in healthcare, etc. So most of the students, because we are interacting today with the students, those who are also public audience who are listening this, when we talk about nanometers, we are talking about a very small scale, which we cannot see through our naked eyes. We need some sort of an equipments like electron microscopes, we need light scattering techniques, or some advanced spectroscopy techniques to detect the nanoscale particles, to visualize the nanoscale particles. So the question comes that how small is nanoparticles? Like 1 nanometer, if we talk about 1 nanometer is a 1 billionth of the meter. It is very small particles. We all have used a meter scale. If we break down a meter scale into 1 billion parts, so the one part is 1 nanometer. Sorry. When we talk about nanomaterials are having unique properties because of its quantum impacts, because of its surface area, because of its biointeractions, and because of its stability, impact, and productivity. But Nanomaterials has to be produced in the safe and sustainable manner so that it can give us the desired impact and the desired applications. So how this nanotechnology can take us to society 5.0 or to address the sustainable development goals. I will talk one by one and the major challenges related to the SDG, which are integrated or collaborated or the basis of all the 17 identified sustainable development goals. Whether, let's start with the human health and the medical care. Nanotechnology can provide the preventive check of various diseases and the robotic cares with precision, which can lead us to lead a long and healthy life and reduce the societal cost. Because when we have preventive check, robotic cares with precision, it can reduce the societal cost as well as improve the life. Similarly, the need of energy. The energy supply, nanotechnology can help us to provide the flexible energy supply or localized energy supply, and which can consume on site. Today, we know that we produce the energy at one site, then we are transmitting the energy through certain grids, and then we are consuming. So what if we produce the energy at site where we are consuming? Of course, we are having certain examples like solar lights at our home or home roofs or at the farm fields, and we are consuming there. So the cost of energy, carrying the energy or the storing the energy or distribution grids can be reduced. And this certainly reduce the cost of energy as well as it will reduce the greenhouse gas emissions because we may use like a lot of renewable resources based on nanotechnology. Uh, the interesting which is like more of one of my core area as well, the food and agriculture. If we can bring the automation in the working or the delivery or improving the texture, nutritional quality or crop productivity, if we can bring automation in the working and the optimal delivery, whether the optimal delivery of processed food which we are getting uh, uh, these days also at the small scale, or the optimal delivery of the farm field. Let's talk about nutrient delivery. These days you might have heard that government of India as well as IFCO and various other organizations are pushing the drone based nutrient delivery, whether it is foliar spray of agrochemicals or the other nutrient delivery using the drone technologies. What these can provide, this can monitor the crop health, same time it can deliver the nutrients with the precision based on the nutrient requirement. As we know that today in an acre area, farmers are applying the dosage same like 100 kg of X or Y or G fertilizer in an acre or in an hectare, farmers are applying uniformly. But we as a researcher, scientists know that every area, even in a small farm field, it might have the different gradient of nutrients of the requirement or the variations. So using the optimal delivery, we can optimize those things that where the need is more or less, and based on that, we can deliver the nutrients. Similarly, the water. We know that earlier we were just plowing the farm field, but these days we are having drip irrigations, we are having sprinklers, and using that, in fact, now we are moving towards vertical farmings or hydroponic systems. So we can save up to 90% of the waters. And even using the less water, less nutrients, we can increase the crop productivity, nutritional quality, the texture, and reduces the food loss by providing the post-harvesting solutions. Similarly, smart industries, we all know that there is a lot of talk about smart cities, which also being developed around the place where we are talking right now. And what this basically the smart industries or smart township or smart cities, it basically the cities, the areas, the clusters having optimal supply chain, whether it is a supply chain of raw materials, whether it is a supply chain related to the processed materials or the things required to make from raw to process, whether it is automatic fabrications of those facilities, infrastructures. What this can solve, this can resolve the problems of the labor shortage. This can increase the productivity, accuracy, and efficiency. Some people who are in general audience listening this talk might wonder that we have a lot of unemployment around. Why we are talking about labor shortage? But we all know the challenges of today and the future. People might have seen in the case of Corona last 2 years, we have learned a lot because of the sudden challenges faced due to the pandemic of COVID. We knew that a lot of labor movement was there, and because of that, a lot of industries suffered. But those industries who were having more automation, they suffered less because in that case, the productivity did not get suffered because of the labor shortage. So the smart industries bring these optimal supply chain and automatic fabrications. And all these points have some sort of nanotechnology based applications in the improving their efficiency or delivery or like that. My research group having expertise in application of nanomaterials in fertilizer, in agrochemicals, whether it is crop nutrition or crop protection, environmental applications and medicines. And our team is more focused on how we design these nanomaterials, whether controlling their shape, their size, or characterizing these nanomaterials at their nanoscale properties so that the designed material can be synthesized and developed for the targeted applications. Our research is more highlighted in the Forbes also in the previous years, and some of the web links are given here to get more details about what our groups are involved in different sectors. I will talk specifically about nanotechnology application in agriculture. And as I mentioned earlier, agriculture is the backbone to solve the sustainable development goals. Nanotechnology, in particularly in agriculture, having its involvement in its pesticides to protect the crop from harmful pathogens, or nanosensors which can detect the crop health, whether it is nutrient deficiency or any kind of other biotic or abiotic stress, whether it is water deficiency, nutrient deficiency, or there is an attack of pathogens on the crop, we can detect as a preventive measure or as an treatment perspective. Then there are nanofertilizers, which can given both by foliar applications, also by soil applications. Seed coating materials, which can improve the seed germination rate, uh, improve the resistance or protection against various abiotic and biotic stresses, soil microbiome manipulations, or soil conditionings. And the genetic engineerings. We used to know that to deliver the gene, we were using gold particles coated with DNA, and then we were using gene gun to deliver the genes in the targeted site of the plants. We all have read in plant science and genetic engineering. Now there are smart nanomaterials which can carry the targeted gene, can deliver to the targeted organelle of the plant cell, including also on the animal cell, but on the plant cell as well, without the requirement of additional machineries like gene gun and so on. Using just a simple foliar spray, we can deliver that. So nanotechnology has more role in this. I will talk specifically about the crop production, and one of the major factor responsible is agrochemical, the fertilizer. You know that why we need sustainability. Whenever we talk about sustainable development goals, we talk about sustainability and precision. So what is sustainability actually is? The sustainability means we can meet the need of our as of today, and we can meet the need of future generations. And it is not about one generation, two generations, it is about several generations of the humanity. So that's what sustainability called for. And if we see this graph, source it from Nature Nanotechnology, on four major crops. If we talk about maize, rice, wheat, and soybean, which is growing globally and consumed globally as well. If we talk from Green Revolution time to 2008, a base year, I have taken here the base year of 2008, that you can see the rate of growth is very not as the growth of the human population. But if we talk about the in with respect to the human population in 2050, or the demand of these things in 2050, we will require more than 2.4% yield improvement every year to double the production of these four major crops up to 2050, and without bringing the additional land under the cultivation with an starting base year of 2008. And we know that the place you are living in today, where we are talking or interacting today, you can see that majority of the agriculture land you are seeing, whether it is Ahmedabad or New Delhi or Vadodara or Mumbai or Jaipur, any city you pick, or even other countries, most of the agriculture land around those cities that expanded into the cities, townships, uh, other infrastructures. Because when the human population grow, it not only required the food, but it also required several other infrastructures. So, what are the current challenges which we are facing? I would like to start with the realization of Malthus. We all have read the Malthus theory in our school time. The Malthus theory tells that the growth of population and its consumption demand, the population grows more faster than the other resources, particularly the food. And then today is the time, or the time is very close, where we are going to face the Malthus trap. We are going to at the verge of the Malthus trap. And when we at the Malthus trap, we need to increase the resources so that the humanity can sustain even at the shrinking farm fields, the climate change, whether it is the resources of natural mineral resources. We all these days are listening the news articles in newspapers, in televisions, and we can see that because of the conflicts in some other part of the world, we can see that there are increasing in the prices of certain resources, of minerals, of natural resources, whether it is fertilizers or oil or petroleum or other energy resources. So the prices are going up and down because of some of the pockets are reserved there. Then diversion of food and biomass energy. We used to grow food for feeding the human and animals, but now we are also growing food or biomass to produce the energy. You know that corn-based ethanol, we are producing rice barn-based oil, similar like that. Then there are some energy intensive process, whether it is water harvesting, whether it is production of the fertilizers. These are very energy intensive. And then because we are doing intense agriculture since 1960, it also affecting our soil biological health. And the major challenge comes from the agrochemical use efficiency. If we talk about use efficiency of the agrochemicals, which are the base to provide nutrition, to produce the more at the smaller land, but if we talk about the major nutrient fertilizers, nutrient inputs, whether it is nitrogen or phosphorus or potassium or any other micronutrients as well, their use efficiency is very less. Particularly in case of nitrogen and phosphorus, the use efficiency is around 30 to 40%. 30 to 40%, and majority of the nutrient which is not taken up by the plants, it is basically going to the environment and cause the non-target impacts. And as you can see that the fertilizer can get runoff, it can reach to our water, it can go to our air and remain in the soil and cause and affect whether it is soil acidity, causing acidic soil, or causing nitrous oxide emission in the air, causing global warming, or polluting water through the eutrophication, where it reduces the oxygen amount and increase algal blooms and creating those red tides problem. There are various developments at regulation level, at research level. If we talk about regulation, there are things related to like 4R nutrient stewardship framework, is talking about right dose, right time, right place, and in right amount. And then there are discussion that who will pay the cost of this, how we can adopt these new technologies like that. And in the course of that, there are various technologies developed over the period of time, whether it is coating of fertilizers. We know that there are neem coated urea in India and other part of the world as well, related to some organic coating, hydrophobic coating, then mixing of multi-nutrients, whether it is macronutrients, micronutrients, enabling them to dissolve, whether it is water-soluble fertilizers or liquid fertilizers, and the co-fertigation, the fertigation or giving inputs to the plants along with biological sources or certain stimulants so that we can increase the productivity, or the reduction in the size where we talk about the nanotechnology. In our lab, we synthesize nanomaterials to solve these problems using the multi-scale physics, impacted by chemistry, impacting transport and depositions. Using these phenomena, these principles, we can make nanomaterials from both from bottom up and from the top down approaches. Our laboratory synthesizing nanomaterials through bottom up fabrications, the example I have provided here, in which we synthesize nanomaterial of different shape, size, morphology, different surface properties, crystal phase properties, and various other quantum properties of nanomaterials. And we use for different applications, including agriculture. Our lab is focusing on various nanomaterials from periodic table to solve some of the big global problems, whether it is related to agriculture, environment, pharmaceuticals, and environment. Particularly if we talk about agriculture, some of the elements I have highlighted here in this slide, which you can see those nutrients are highly explored or explored based on scientific publications or scientific literature, being explored their application and role in agriculture. And largely, if we see, they are the nutrients of the plant. These are playing role as nutrients. But there are some nutrients, whether it is silver, gold, titanium, cerium, these are not the plant nutrients right now, but because the ease of controlling the nanoscale properties on these elements, these nanomaterials are also being explored for the fundamental studies on the plant science. And they are easy to scale up, easy to control the properties, and they require in less quantity, or they are in cost effective. Once we produce any kind of nanomaterials or any kind of an engineered materials, it is essential that we should test those materials in the controlled environment. Because every time when we talk about sustainability, we talk about precision, we have to be there, we have to be ensured that the material we are producing is safe and sustainable. So we test these materials in the controlled environment, whether it is hydroponic settings, aeroponic settings, or the controlled field trial settings. And once we do these field trials, we take the product to the next level for the different regulatory studies and approval. I would like to share one of the recent example, that in India, there is a product was introduced by Indian Farmers Fertilizer Cooperative Limited, which is India's largest fertilizer marketing and manufacturing company, which launches a product called IFCO Nano Urea. The Nano Urea is a nitrogenous fertilizer based on nanotechnology, and this is an alternative of conventional urea granular fertilizer. This product has been included in the fertilizer control order, which basically regulate all the fertilizer products in India. This product has been evaluated by various scientific bodies of India, like Department of Biotechnology, Indian Council of Agriculture Research, or Council of Scientific and Industrial Research, CSIR, in addition to farmers or Krishi Vigyan Kendras or the other stakeholders like other industries, etc. So how this nano urea is different than urea? I'm just giving you a glimpse of an example that how nanotechnology can help achieving the sustainable agriculture, which can lead to the achieving the sustainable development goals. This nano urea is having the particle size of 20 to 50 nanometer. When we compare to conventional urea, which is 1 to 3 millimeter in size range, on an average, they are around 2.8 mm in size. When we talk about smaller size, the nanoparticles of the nano urea having very high surface area compared to volume size ratio. It has advanced physicochemical properties which is much improved than the conventional bulk counterpart. It has better uptake ratio at the lesser volume, and it provides better uptake efficiency. It has controlled release kinetics and improved biointeraction, so that even at smaller quantity, this material can provide the equal or better impact than what the conventional bulk counterpart is providing. This product has been tested for its efficacy and efficiency, safety. As you all and may aware that Government of India, the Department of Biotechnology, has launched a guideline to test nanotechnology-based agri-inputs, and they have also launched nanotechnology guideline for evaluating nanopharmaceuticals and nanotechnology application in medicine as well through Department of Biotechnology. This nano urea has been tested for the safety of flora and fauna around the farm field based on national and international protocols, whether it is OECD protocols or other international protocols required for the regulatory registration and so on. Nano urea also tested across India on different geographical conditions, different agroclimatic conditions, on various crops. It's called multi-location, multi-crop trials, and found that this product not only reduced the use of conventional urea by 50%, but it also increased the crop productivity. It also enhances the nutritional quality. This product is approved by the Government of India. It has been communicated widely to the farmers, to the other stakeholders, and it has economical impact, economical benefits plus environmental benefits. It can save the huge subsidy burden given by the government of is on Government of India to procure and distribute the fertilizer to the farmers at the affordable cost. So today, the urea bag of fertilizer or other fertilizers costing a huge subsidy which can be saved by the use of nanotechnology-based inputs. Uh, since there are a lot to talk about nano urea, because that's the product that we developed and translated to the farmers, so there may be a lot of questions. So we have a dedicated website, nanourea.in, where you can get more information about this product and the other informations related to this. uh, so we are at the end of the talk. This talk was sourced based on various publications on the internet. In terms of summary, using the agriculture, which is a base to achieve almost all the sustainable development goals, we require smart and precision inputs in terms of whether it is crop nutrition or crop protection, which you can achieve through nanotechnology in terms of targeting variable or control release, keeping the plant available form, reducing the requirement by mass volume, or improving the agriculture productivity and sustainability using uh, various nanotech-based applications to monitor the crop health, to provide the nutrition, to protect the crop. So with that, I would like to thank all of you, and I would like to acknowledge my organizations, institutes where I have worked or I am working or I have collaboration with. So I would like to thank you all and would like to end the talk here.
Thank you so much, sir. Sir, if you permit, my
Yes,
students is asking one or two questions.
Wait.
Yes, sir.
yes, yes. I would be happy to take the questions of the audience.
Okay, sir. Sir, how this idea related to nano urea that is come, and when you did the started working on it?
Uh, well, so you know that uh, we all know that as a researcher, as a student, that how the huge efficiency of agrochemicals, particularly like fertilizers. And I born and brought up at the farm field, and I have seen my family that growing various crops, and they are procuring fertilizers since my school days every year more than last year, and the crop productivity more or less remains same over the period of time. So That basically drawn my interest in agriculture, that how I can help millions of people out there on farm field like my parents. And that's how I started working with the World Bank funded project in Indian Council of Agriculture Research, and then at Washington University in St. Louis, where we played with different kind of materials and we tried to deliver them. And we found that when we create materials at the nano scale, it basically enhances the absorption by the plant system. And then we thought that once it can increase the absorption, means the urea, let's say in example, we provide 100 kg urea, around 30 to 40% taken up by the plants, but 60 to 70% going into the environment. Then we thought that how if we can increase the absorption of this. So once we can increase the absorption, then we can increase the crop productivity. And then we played with the materials by different kind of coatings, by reducing their size, and then different delivery systems, whether it is foliar spray, drip irrigations, different fertigation techniques. And we found that we can achieve the increasing the efficiency up to 86% or even more in some controlled conditions. And that basically led us to this development of nano urea. And now this product allowing us not only increasing the absorption, but also the controlled release of nutrients. You know that when we provide nutrients, when we talk about use efficiency, how it is affected that the nutrient get transformed from one chemical form to another chemical form. It is just like food in our kitchen. Like when we have a hot, tasty food on our table, and if we are getting delayed due to like any reason after 2 hours, 3 hours, we don't like that food that much as we like the hot food or the tasty food that we want in that particular form. So the same way is for the plants. If the chemical form change, plant do not uptake that nutrient, even the nutrient is present in the soil. If we go take the a spoon of soil from our farm field, we find that there is a huge amount of total phosphorus is available. But if you check the available phosphorus, which is always much lesser than what the plant requires. So thereby, every year we are putting more and more fertilizer to the farm field. And when we put more than what it required there, because of its lesser use efficiency, certainly it will go to the different environment system, because agriculture is an open system, open ecosystem, where we are giving certain inputs in terms of agrochemicals, we are harvesting the crops, and meanwhile there are certain losses of these inputs, whether it is into to the air or water or remain in the soil. Some part we are harvesting in terms of grain or biomass. So thereby this concept came in our mind that how this creating these nanoscale particles, increasing their surface area, even requiring less, how they can improve the agricultural efficiency. And with this nano urea, we have found that it can reduce the requirement of the bulk material consumption and increase the agricultural productivity. And I would be happy to share with the audience that Indian Farmers Fertilizer Cooperative Limited, which is an farmers organization, which developed this nano urea here at the Nanobiotech Research Center in Gandhinagar, Gujarat, and also developed a manufacturing facility where every day you can produce more than 75,000 liter of nano materials, which means like our package size is about 500 ml, which is more than 150,000 bottles every day to serve the Indian farmers at the affordable price. Because in agriculture, it is also important, because I know that this talk is also from the College of Agriculture. So in agriculture, it is very important that you can produce the technology, but the technology should be at the affordable price. Because if we produce some material which is costing $1,000 per kilogram, the farmers won't be able to access it or afford it. Whether it is the farmer of India, or farmer of Africa, or any part of the world. Because when we work on science, we work for farmers of entire world. So we should develop the technology which is accessible, and that IFCO has established that the technology can be developed, can be innovated, the breakthrough can be brought at the affordable cost, and can be distributed. And India is, and also I would like to share that India is not only providing this nano fertilizer to Indian farmers, but also to the neighboring countries. Like recently, might have heard that India given the urgent assistance to Sri Lanka when they banned the chemical fertilizer.
Sir, is there anything from your side? Dean, sir?
Dr. Ramesh, thank you very much. I think we have discussed a lot and regarding the nano, how we are utilizing, and it gives a kind of opportunity to be utilized in the polyhouses where we spray in the form of the mist also, and in the hydroponics, which is a kind of the opportunity for such kind of the farmers. We can say the progressive farmers. Generally, we discuss with our students, they have a kind of inclination whenever we form the nanoparticles, because my students are working in the nanotechnology, we use the silver nanoparticles and the gold nanoparticles. There is a kind of a problem of the aggregation whenever we form the nanoparticles in that case. How this problem is avoided in the case of the nano urea?
That's a very good question because whenever we make any kind of material, it comes in contact with environment. And when we talk about environment, environment can be in vitro or in vivo. Like if we talk about, like for example, cell culture or a microbial growth medium or the soil medium. So all are different kind of environment based on application. So nanomaterials has tendency to come together because what we have done that naturally the particles tendency is to come close and together, get aggregate. Like similar tendency in human as well. They go and stay closer in an aggregated form, whether it is village or cities or in the cluster form. So these nanoparticles also make and form the cluster because this is a tendency of the nature. But how we can keep them separate? Similar to our house, we can make them certain walls. We can identify the factors responsible for it. So nanomaterials get aggregated because of certain surface properties, such as surface zeta potential, the surface charge of the particles. And then, if we control the surface charge of the particles and the charge, the medium in which we are having these particles dispersed, this medium can have the control in terms of physical or the chemical factors. Physical factors, like for example, temperature. Chemical factors, such as, for example, the pH, a very simple example. This temperature and pH influences the particles' stability. And then, so there are of the materials or template we can use to control these particles interaction. We can reduce the particle interaction and increase the Brownian motion. We can induce the Brownian motion so that particles remain in the individual particle form. They will keep moving in the solution, but will not get settled down. They will remain in the particle form. So certainly that can be engineered by engineering the surface of nanoparticles. So, but if we, and then based on our intended applications, because nanotechnology is being explored now, it is more than 30 years very actively. So there are materials have been developed in which you can, when you want to store the material, you can keep with the coat, certain coating, and then based on your target applications, that coating can be selected so that you apply those particles, you don't have to remove the coating because when they go and contact with your target application, the active ingredient get released in the nanoform and get the pigment. So that's what we have done in nano urea as well by controlling the surface properties of the materials so that active ingredients remain in the nano form and our particle size is very monodisperse. I would say 20 to 50 nanometer in physical size, like every day, and we have scaled up of 75,000 liter every day with the controlling the particle size at the same point.
Dr. Ali, I think it will be a kind of opportunity for us and IFCO also, if we can collaborate for working together with our research scholars, those who are working in the nanotechnology, that will be the good for our society also. So I think we can explore, if you permit, we can explore such kind of opportunities for the students.
Absolutely. IFO is a farmers organization, and we are always open to exchange our ideas, to exchange the facilities, to exchange the resources and innovations in the betterment of our country or betterment of the human society and the knowledge sharing. And as the great people said in past, that knowledge is the one thing that the way you share, we will gain more and more.
Indeed.
So, and the university is a breeding ground for the knowledge, for developing the futuristic technologies, ideas. So we would be happy and glad to collaborate wherever the possibility arises.
Thank you very much. Thank you very much for that.
And I would like to inform you that the IFCO has a collaboration with the ICR, Indian Council of Agriculture Research, with IIT Delhi, and several other universities. So certainly there is a possibility that we can find our common scope and we can work with your students and extraordinary faculty there.
Thank you very much. Thank you very much. I think we can explore. That will be a kind of opportunity for the students as well as the
Sure.
faculty, those who are working.
Thank you, sir. Uh, Now, by your permissions, let's move on, sir.
Sure.
So it's
Just
a
one thing.
matter of pride for me that I'm.
Tariq ji, Tariq ji.
Yes, yes, sir.
Just one thing that
Yes, sir.
because there was, I think, very little question from audience. So if anybody has question, can send their question by email as well. We would be happy to answer those questions.
Sure, sir. Sure. Thank you so much. Now it's a matter of pride for me that I'm proposing vote of thanks for this informative webinar and productive. I, Mohammed Tariq, on behalf of my college and entire family of Parul University, first of all, I spread my most sincere thanks to the God. I would like to thank uh, uh, Chairman of this webinar, Dean and Principal, Faculty of Agriculture, College of Agriculture, Dr. Chandrakant Sarma, sir, for his enthusiastic support. I want thank to the speaker, Dr. Ramesh Relia, sir, who gave his vital time for his busy schedule to grace this webinar. Thank you so much, sir. A special thanks to the teaching and non-teaching staff for their support and coordination, sir. Especially and heartily thanks to our students for active participations. And with these warm words, I kind message, we will move to end of today's webinar. Thank you so much, sir. Thank you all.
Thank
Thank
you.
you.
Thank you, sir.